The next section is 11.3 perimeter and area of similar figures. So we have theorem 11.7, which is the areas of similar polygons. If two polygons are similar with the lengths of corresponding sides in the ratio of A to B, then the ratio of their areas is A squared to B squared. We can see the two polygons are similar due to this symbol here. And this symbol means that the two figures are similar. So if we have the side length of polygon 1 over the side length of polygon 2, all we're going to have is A over B, which is the length of both of their sides. However, if we have the area of polygon 1 over the area of polygon 2, we're going to have A squared over B squared. This is very important to recognize that when we have the area, it's going to be A squared over B squared. So the sides are just A over B. The perimeters are going to be A over B, but the areas will be A squared over B squared. And we will get to the volumes in a later chapter. So let's work out this first example. It says find the ratios of similar polygons. In the diagram, triangle ABC is similar to triangle DEF. Find the indicated. And so for A, we need to find the ratio of the perimeters. And if you remember, the ratio of the perimeters is just A over B, or side over side. So we're going from red to blue, so the ratio of the perimeters will be 8 over 12, which simplifies down to 2/3. Now we need to find the ratio of red to blue of the areas. And when we do this, we need to square both of our side lengths, so we would have 2 squared over 3 squared, which would come out to be 4/9. So when we're dealing with area, remember we need to square both of the side lengths, or when we're dealing with perimeter, we also can square that. Alright, so for example 3, we have a rectangular baking pan is 15 inches long and 10 inches wide. A smaller pan is similar to the large pan. The area of the smaller pan is 96 square inches. Find the width of the smaller pan. So, first thing we need to do is draw a diagram, and we have a diagram drawn out for us. So, what we're trying to find is the question mark. So, we have side lengths and we have areas of both of these. If we were to set this up, I want to say our length is 15 and our width here is 10. Now, what we're trying to find is this question mark over here. We can say this is W, X, you can use whatever letter you want. I'm going to use W because we're trying to find the width of the smaller pan. So if we were to set this up, we would say 10 over W, and now we would set that equal to the areas, which would be 150 over 96. And is this how we set it up? No, because remember, we're dealing with areas. So if we have an area on the right and we have a side length on the left, we need to square our side lengths to make it equal to the area. You can see 10 goes with 150 and the W goes with a 96. And now this is all we need to simply do is cross multiply and solve. When you cross multiply, you should get 150 W squared is equal to 9,600. And divide by 150 on each side, we will get W squared is equal to 64. Square root both sides, and we will say W is equal to 8. And that's a positive 8. When you square root, remember you have a positive and a negative, but we cannot have a negative dimension, so we're going to have 8. And do not forget the label, we will have 8 inches. And it's only inches because we're dealing with a side length. Remember in previous videos when we were finding the area, we would have something like inches squared. But because we're using just a side length, it's only inches for the label. And for the next example, we are installing the same carpet in a bedroom and den. The floors of the rooms are similar. The carpet for the bedroom costs $225. And carpet is sold by the square foot. How much does it cost to carpet the den? Okay, so let's use some of the information that we're given. We are given 2 side lengths, and we are given how much it costs to carpet the bedroom. we're trying to figure out how much it's going to cost us to carpet the den. This is set up very similar to the last problem. So we have our two side lengths, and we can say we have 10 over 14, and we can set that equal to, remember we're trying to find the cost of the den, so the 14 goes with the den, so that's on the bottom, X, and X represents the cost of the carpet for the den, and what would go on top? That would be our 225. Are we done? No. Remember, we are dealing once again with area because we are saying that the carpet for the bedroom is $225, and that's for the entire bedroom, and that's by the square foot, which is area. So if we have area on the right, that means we need to take our side lengths and we need to square them. And after you cross multiply, you will get X is equal to $441. So the answer here would be D. Here for our last example, we have the perimeter of triangle ABC is 16 feet and its area is 64 square feet. The perimeter of triangle DEF is 12 feet. Given that triangle ABC is similar to triangle DEF, find the ratio of the area of ABC to the area of DEF. Then find the area of DEF. The first thing we need to do is figure out what we have in common. We are given that triangle ABC is similar to triangle DEF. To compare the two triangles, I'm going to put triangle ABC on top and triangle DEF on the bottom. We're given two perimeters, and that means we can set up our ratio. So if I have ABC on top, I'm going to say that the perimeter for ABC is 16 over the perimeter of DEF, which will be 12. And we can simplify this. If we divide both of these by 4, we should get 4/3. Since we have the ratio of our perimeter, let's bring that down here. We have 4/3 is equal to, we are trying to find the area of DEF. So that means that X goes on the bottom here, and we're given the area of ABC, which is 64. And remember, anytime we're dealing with perimeter or side lengths, we need to square those values to set them equal to the area. So we should have 4 squared over 3 squared is equal to 64 over X. And if we cross multiply here, we should get 16X is equal to 576. Divide by 16 on both sides, and we will get X is equal to 36. And now remember, we're dealing with area, so let's look back at our label. We should have feet squared. Feet squared because we're dealing with area. Always remember though, when we're giving perimeters or side lengths, we need to square those values to set them equal to the area. And this will conclude 11.3.